Hello everyone and welcome to Kiru's online lectures. I am Kiraj Jhamtani and today's topic is surface area and volume part 2. See in part 1 we studied introduction and surface area of the combination of solid figures. Now in part 2 we are going to study volume of the combination of the solids. So moving on to volume of the combination of solids. Here the concept is like we are provided with a cone which is surmounted by hemisphere. So the volume of the combination of the solid will be volume of cone plus volume of hemisphere. Then in first part, we studied these formulas. Volume of cone is 1 by 3 pi r square h. Volume of hemisphere is 2 by 3 pi r cube. So this is how we have to apply the concept of volume of combination of solids. Moving on to the question part, the first question is a solid is in the shape of a cone standing on hemisphere with both their radii being equal to 1 centimeter and height of the cone is equal to radius. So this is a cone which is standing on hemisphere. This radius is r only, which is equals to 1 centimeter. Height of the cone is equal to radius. That means height is also 1 centimeter. And now we have to find volume of the solid in terms of pi. So volume of solid is equals to volume of cone plus volume of hemisphere. The formula of volume of cone is 1 by 3 pi r square h plus 2 by 3 pi r cube. Now substituting the value of r and h over here, since r is equals to h, which is equals to 1 centimeter, so we'll get 1 by 3 pi plus 2 by 3 pi. Thus, we'll get 3 by 3 pi, which is pi centimeter cube only. So this is how we have to apply the concept of volume of combination of solids. Moving on to next question. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminium sheet. The diameter of the model is 3 centimeter. Length of the model is 12 centimeter. If each cone has a height of 2 centimeter, we have to find volume of air contained in the model that Rachel made. Here, assumption is made that outer and inner dimensions of the volume are of the model to be nearly same. So now it was cylinder with two cones and diameter of the model is 3, that means radius is 1.5. Total height of the model is 12 centimeter. Height of the conical portions is 2. So the height of cylindrical portion will now come out to be 8. Now since we have to find over here the volume of air contained in the model, so volume of air contained in the model will be volume of two cones plus volume of cylinder. So 2 cones is 2 into 1 by 3 pi r square h. So pi r is 1.5 square into height of conical part is 2 plus volume of cylinder pi r square h. R is again 1.5 square into h is 8. So from here we can take 1.5 square into pi common. Thus we'll get 2 into 2 4 by 3 plus 8. Thus on solving it we'll get 1.5 into 1.5 into 22 by 7. We'll take LCM. 8 into 3 24. 24 plus 4 28 by 3. So 7 into 4 and here 3 into 0.5. Thus we'll multiply it. So we'll get over here 66 centimeter cube. So this is how we have solved this question, in which we calculated the volume of air contained in the model. So volume of air contained in the model is equals to volume of two cones plus volume of cylinder. Now next question is, gulab jamun contains sugar syrup up to 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends. Now these are like cylinder with two hemispherical ends. Total length of the gulab jamun is 5 centimeter. Diameter is 2.8. That means radius will be 1.4. Now if radius is 1.4 of hemisphere, so height is also 1.4. So this total length of the gulab jamun is 5. So 5 minus 2.8. So the length of cylindrical part will be 2.2 centimeter. Now since we first will calculate volume of one gulab jamun. So volume of one gulab jamun will be volume of two hemispheres plus volume of cylinder. So it will be 2 into 2 by 3 pi r cube. R is over here 1.5 cube plus pi r square h. R is 1.4 ka square into h. Height of cylindrical part is 2.2. Thus when we'll solve it, so we'll get 25.07 centimeter cube. This is volume of one gulab jamun. Now we have 45 gulab jamuns. So volume of 45 gulab jamuns will be 25.07 into 45, which is equals to 1128.5 centimeter cube. Now we have to calculate volume of syrup. So as they mentioned in question that syrup contains 30% of its volume. So whatever volume we got, we'll calculate its 30%. So 30% of 1128.15, this will come out to be 338.45 centimeter cube. Hence, there would be approximately 338 centimeter cube of syrup in 45 gulab jamuns. Coming on to next question. Now the question is, a pen stand made of wood. It is in the shape of cuboid with four conical depressions to hold pens. The dimensions of the cuboids are 15, 10 and 3.5 centimeter. Radius of each depression is 0.5 centimeter and the depth is 1.5 centimeter. Now we have to find the volume of wood in entire stand. Now see, as this is a cuboid shape, now pencils are hold over here like this. So if we have to find volume of wood contained over here, so it will be cuboid minus this conical portion basically of the pencils. So when we have to find the volume of wood which is present in the entire stand, that volume of wood, it will be volume of cuboid minus volume of four cones. So cuboid is length into breadth into height, its volume. Four cones is 1 by 3 pi r square h. Length is 15 into 10 into 3.5 minus 1 by 3 pi 22 by 7. The radius is 0.5 square into height is 1.4. So 15 into 10 into 3.5 will come out to be 525 minus 1 by 3 into 22 by 7 into 0.5 into 0.5 into 1.5 will come out to be 0.366 centimeter cube. We'll subtract it, we'll get 523.5 centimeter cube. Now the next question is, solid iron pole consists of cylinder of height 220 centimeter and base diameter of cylinder is 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Here we have to calculate mass of the pole that 1 cubic centimeter, given that the 1 cubic centimeter has approximately 8 gram of mass. Now we'll calculate volume. Now because they have given us the 1 centimeter mass of 1 centimeter cube of iron is 8 gram. So whatever volume will come, we'll then multiply it by 8 and thus we'll calculate mass of the pole. So over here it is given this is one cylinder whose diameter is 24, that means radius will be 12 centimeter and its height is 220 centimeter. Now it is surmounted by another cylinder. This another cylinder has radius 8 centimeter and its height is equals to 60 centimeter. So over here we have to calculate the volume. So volume will be volume of first cylinder, volume of total solid will be volume of first cylinder plus volume of second cylinder. So volume of solid is equal to volume of first cylinder plus volume of second cylinder. Thus, it will be pi r square h plus pi r square h. So here for the first cylinder, it will be pi into r is 12 square into h is 220 plus pi, here r is 8 square into 60. Thus, when we'll solve it, we'll get 99,475.2 plus here we'll get 12,057.6. On adding it, we'll get 111,532.8 centimeter cube. Now, since they have given mass of 1 cubic centimeter is 8 gram. So, mass of 1,11,532.8 centimeter cube will be 8 into 1,11,532.8, which is equal to 8,92,262.4 gram. We'll divide it by 1000 to convert it into kilogram. We'll get 892.262 kg. So in today's video, we studied the volume of the combination of solids. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.